Alright, so this video is going to cover Unit 6 assignment number 1. Really four major things. First, the fundamental counting principle and how that relates to factorials, and then permutations and combinations. So let's go ahead and get started. So this first problem, a handsome guy named Troy goes out to eat with his new girlfriend, and he decides his new girlfriend can order steak, chicken, or pork. Can have one side, potatoes, beans, or macaroni and cheese, or a corn muffin. And it can have one dessert, cheesecake or carrot cake. So we can make a factor tree of this. Not a factor tree, but a tree diagram of this. If we talk about the main dish here, there's three different main dishes he can have: steak, chicken, or pork. And then if off the main dish we get the side dish can be one of four things: potatoes, beans, macaroni and cheese, or corn muffins. So it's four things coming off of the steak. In other words, you can have steak and potatoes, steak and beans, steak and macaroni and cheese, or steak and corn muffins. Same thing coming off of the chicken, same thing coming off of the pork. And so that's a total of 4 sets of 3. That's 12 different items. And then he can have a dessert, and the dessert is 2 things. It's either cheesecake or carrot cake. So off of each of these 12 things, they can have cheesecake or carrot cake here, cheesecake or carrot cake here, and here, and here. So that's 12, but each one of those 12 items has 2 things coming off of it. That's a total of 24 different options. Easier way of doing this is to go with his number of choices. He has 3 choices for a main dish, times 4 choices for a side dish, times 2 choices for the dessert, and 3 times 4 times 2 is equal to 24. That's the fundamental theorem, or the fundamental counting principle. If I have so many options, and if I want all those things to happen, or to find all the combinations of all those different options, I just multiply them together, and that's 24. Let's take a look at a different example. So suppose we were to give you a quiz, and you didn't know what the questions were. You just had to guess. Let's say you said number 1 was A, number 2 was C, number 3 was true because it's true or false, number 4 was false. Let's just say you guessed, and you wanted to figure out how many different ways could you guess the outcome of all of those things. Well, number 1, you had an option of 4 different things. Number 2, you had an option of 4 different things. Number 3, you had an option of 2 different things. And number 4, you had an option of 2 different things. And so to find all of the options, we would just multiply all those together. And 4 times 4 times 2 times 2 is 64 different ways. All right, so now we're going to move on to factorials. It's kind of the same thing. It's just a different added thing on here. It says Troy is arranging his 5 favorite love songs on a CD to give to his new girlfriend that he went out with once. How many different ways can he arrange his 5 love songs on a CD? So he has 5 different songs he wants to put on the CD, and he wants to arrange them in a certain way. So the first way would be he has 5 choices for his first song, and maybe that's his favorite. And then after he chooses his first song, he's going to have 4 choices left for his second song because his first song's already been picked. So he has his first 2 choices, then he has how many songs to choose from left, and that's 3 songs. Once he picks his top 3, he only has 2 songs left, and then 1. Well, we want to multiply 5 times 4 times 3 times 2 times 1. Another way to do that is on our calculator using the factorial button. That's not 5 exclamation point, that's 5 factorial. And you can find this on your calculator if you press Math and then go to Prob. That's the second one from the right. And then number 4, it looks like, is the factorial button. And you can see that 5 factorial, I better do this, 5 factorial I think is 120. Yes, 120 different ways. All right, so number 1 is 120. And then after giving her the CD, he decided he would tell her the top 10 reasons why he loved her. How many different ways could he arrange his top 10 list of reasons why he loved her? Well, again, he can name, there's going to be 10 different ways. He has 10 reasons, and he wants his best to be first, so he picks his best reason first. And then he has 9 left. After he picks his first 2, he's got 8 left, and then 7 and 6 and 5 and so on. And we're going to multiply all those together. We could do it individually, or we could just say this is 10 factorial. And if you were to take 10 factorial on your calculator, that would give you a total of 3,628,800 different arrangements of his top love songs. Let's move on. Now let's talk about permutations. It's kind of the same thing as factorials, except we're not going to go all the way down to 0. So for example, let's say you want to determine how many different ways there are of selecting a first, second, and third place prize for your class of 24. So let's say at the end of the semester, I'm going to give these awards out, and I'm going to pick the very best student that I have out of 24 kids. Well, I have 24 kids to choose from. Once I pick my top kid, I want to get the second place prize. Well, I have 23 kids left to choose from, and then finally I'm going to have 22 kids left to choose from after that. So I could just simply multiply 24 times 23 times 22. That's going to give me 12,144 different ways. Well, another way to do that is to take 24 factorial divided by 21 factorial. 24 factorial means 24 times 23 times 22 times 21, all the way down to 1. 21 factorial means 21 times 20 times 19, all the way down to 1. Well, if I'm multiplying all these together, the 1s will cancel, 2s will cancel, everything will cancel up to 21, and what I'm left with is 24 times 23 times 22. This is the exact same thing that I had at the beginning. So I could take 24 factorial divided by 21 factorial, and in fact, that's what your calculator does when you use the permutations button. Okay? You can find this. First you press 24, and then you go to math, go over to probability, and then you see the NPR button, which I think is number 2. If you press that, you're picking 3 people out of 24. So then you select the 3, press enter, and you can see that you get 12,144. There are 12,144 different first, second, and third place arrangements out of a class of 24. That's a permutation because order matters. So one of the things you're going to have to remember about permutations is that order matters. First, second, and third is different. If Bill gets first, that's different than if Bill gets second. Okay, so order matters on permutations. So if we go on to combinations, well, let's say we have, let me get rid of this first. How many ways are there of selecting the top 3 students of a class of 24? So this is a little bit different because now I just want a group of 3. So I can pick Al, Bill, and Chris, or Bill, Chris, and Al. It's the same thing. Chris, Al, and Bill, or Chris, Bill, and Al, they're the same thing. Let's say we start with this assumption. We're going to have 24 people to choose from for our first spot, times 23 for our second spot, times 22 for our third spot. Well, that's the permutation part of this, and that would be, let's say I have Al and Bill and Chris. Okay, well, one of those possibilities is Bill and then Chris and then Al. Another one would be Al and then Chris and then Bill. Another one would be Bill and then Al and then Chris. And then we'd have Chris and Al and Bill. And finally Chris and Bill and then Al. In other words, that you can see there are 6 different ways to arrange those 3 people. So I don't want all 6 of them to be included because to me these are all the same thing. So I'm going to divide how many times I'm repeating these numbers. Well, I have 3 numbers, and so that's how many different ways can I arrange 3 numbers? Well, if I have 3 numbers or three people, I have 3 people to choose from for my first spot, 2 for my second, and 1 for my third. That's 3 factorial. So in other words, I can take, this is division sign here, I can take 24 times 23 times 22, I can take that, and then divide it by 3 times 2 times 1. That's one way to do it, because the 3 times the 2 times the 1 are repeats, because order doesn't matter on how I select them. Well, that's the same thing as this. I can take 24 factorial, let me rewrite this over here, I can take 24 factorial divided by 21 factorial. That's the same thing as 24 times 23 times 22. But then I want to divide that by 3 factorial. Well, another way of writing this expression is to take 24 factorial over 21 factorial. If I multiply this by the reciprocal, that means I'm multiplying by 1 over 3 factorial. Well, that means the top would be 24 factorial and the bottom would be 21 factorial times 3 factorial, which is what you see here. That's exactly what your calculator does when it uses the combinations button on your calculator. So you can see this right here. You can do that on your calculator as well by pressing 24 first, going to math, going over to probability, going to NCR, because here it doesn't matter what order those 3 people are in. I'm going to go NCR, and again I'm picking 3 people. And so now you can see there's only 2,024 different ways of selecting the top 3 individuals. So if at the end of the semester I give awards to the top 3 people in the class, and there's 24 people in a class, that means there's 2,024 different ways to give out those awards. All right, let's try one of these and see if we can figure out if it's a permutation or combination. So it says you want to elect a president, vice president, secretary, and treasurer from your club of 12 members. Well, the first thing we have to figure out, is this a permutation or is it a combination? So you have to ask yourself, if you have Al, Bill, Chris, and Dan, and Al's the president, Bill's the vice president, Chris is the secretary, and Dan is the treasurer, is that different than if I mix up the order? And it would be. We want to have a specific person as the president, and then another specific person as the vice president. So here order matters. So this is going to be a permutation, which means we are going to do it one of 3 ways. I can either go 12 times 11 times 10 times 9, or I can take 12 factorial divided by 8 factorial, or I can simply take 12, a permutation of 12 picking 4 is how we would say that. A permutation of 12 picking 4, which is 11,880 different president, vice president, secretary, and treasurer combinations. Let's take a look at another example. Here's number 8. Here you want to elect an advisory committee of 4 people from your 12 members. So you're not going to have specific roles of those advisories. They're just going to serve on a committee, all 4 of them. So here it doesn't matter. If you pick Al first, or Bill first, or Chris or Dan first, it doesn't matter. So that means order really isn't going to matter. This is going to be a combination. I would take it 12 times 11 times 10 times 9 divided by 4 factorial, or I can take 12 factorial divided by 8 factorial divided by 4 factorial, or the combination of 12 picking 4, and that's 495 different combinations of a committee of 4. Well, how about your locker combinations at school? So Homestead lockers have 50 numbers on the dial. How many locker combinations are possible if you cannot repeat the numbers? Well, that would look something like this. That would mean I have 50 numbers to choose from first, and then I would have 49 to choose from second, and 48 to choose from third. If order matters, which it does, a combination of 6, 26, 32 is different than 32, 6, 26. So order does matter. This is going to be a permutation, and I would take 50 factorial divided by 47 factorial, or I could just take 50 factorial divided by, or 50, a permutation of 50. I'm doing that on my calculator right now, but I messed it up. Let me start over here. A combination of 50, a permutation of 50, where I'm picking 4. And if we do that on our calculators, we get you get a 117,600. So instead of calling them locker combos, It's really a permutation. It really should be called